complex number operations, and now we're on dividing. So first of all, we need to know that dividing, when we're talking about rationals or complex numbers, is mostly just a simplifying of fractions. We're not going to actually do any dividing itself. We're not going to do long division. We're just simplifying fractions. So if you look at that in that terms, it does make things a lot easier. So there's a number one rule when we're talking about complex number operations with dividing, is that I in the denominator is improper. So that's the biggest problem here. And then we want things in its simplest term. Make the simplify. Okay. So we want things in the simplest term. We want to make sure that I is not in the denominator, and then we can go ahead and do this problem. All right, that's our two biggest rules. So as long as we understand those things, then we're good to go. So we're going to have some simple steps. Step one, my advice is always simplify first. Even though we're going to go back and we're going to do it again. The second thing we're going to do is rationalize the denominator. And then, as always, I want to go back and simplify one more time. I want to make sure I'm in my simplest terms, because if I'm not, then it's not going to be a correct answer. And you did all this work for it to be wrong. Okay? So what I want to do first is I want to focus in on the 12i to the 5th power divided by 6i. And so I'm going to do this problem just by simplifying. And then I'm going to teach you what it means to rationalize the denominator. And we're going to go back and do this problem again. All right? So it sounds like a lot of work, but it's mostly to get you to understand what's happening. Okay, so the first thing we're going to do is simplify. Right? When I say simplify, I'm looking at the first part of 12 divided by 6. And 12 divided by 6 is 2. And then I to the 5th divided by I. Well, that just looks like, let me write it down here, I to the 5th over I. Write those two cross out. So this just is I to the 4th. Well, what do we know about I to the 4th power? We know that I to the 4th power is just 1. So then 2 times 1 is 2. Pretty simple. So this whole problem just turns into 2 when we simplify. I'm going to go back and do this problem one more time with the whole rule of rationalizing the denominator without simplifying first and see what happens, okay? But what does rationalize the denominator actually mean? Well, we're not allowed to have a rational in our denominator. That's improper. Like, what? These aren't rationals, these are radicals. Remember that I is equal to the square root of -1. So it is a rational down there. And we don't want that. That's considered improper. Okay? So to do that, all we do is take the problem, and we're going to multiply it by I. And technically it's going to be I over I, so I should write that in a proper format. I over I, because what you do to the bottom, you do to the top, is keep the problem equal. This is just multiplying it by 1, so nothing is changing here. Okay, so let's go ahead and do that. So let's first check. Do I need to simplify this problem? 9 over 2, that doesn't simplify. There's only one I, so it's not going to simplify either. So let's go ahead and multiply by I over I, okay? So what happens here? This becomes 9i over 2i squared. And what do we remember about I squared? It is just -1. Now, I'm going to work this problem out, but there will be a point where I stop just for the sake of time. So this becomes 2 and then times -1. And 2 times -1 is -2 over 9i. Right? You might see it written like this, or you might see it written as negative and then 9i over 2. Right? That negative sign properly is written in the front, but you can keep it like that. It's not going to be wrong. But if you have a multiple choice test, right, you're not going to see it with the -2. You're going to see the negative out in the front. Okay. So I do want to go ahead and go over why it's important to simplify first rather than just rationalizing by the denominator. So I'm going to go back to this problem here. Remember, our answer was 2. So I'm going to erase this part so I can focus in. So what happens if I just rationalize the denominator? If I multiplied it by I over I, right? That's what we're going to look for. So I'm going to erase all this. We know the answer is 2. We did the work. Hopefully you have it written down. So what happens? Well, this becomes 12I to the 6 over 6I squared, right? We know that 6I squared, that's going to be 6 times negative 1, so makes this a negative 6. What happened to the I to the 6th power? Well, if you remember our previous rules, 6 divided by 4 is 1 with a remainder of 2. So this is going to be 12I squared. Okay, 12I squared, we already know I squared is just negative 1. So this is now negative 12 over negative 6. And negative 12 over negative 6 is 2. So this is that answer here. Let me see. I want to move some stuff around. Please forgive me because I want to be able to compare and contrast. I believe that's important. All right. I'm going to copy this. Copy. And then I'm going to go back to what we had before because I want you guys to see the process that we just went through here versus here. Notice how there was more steps. Even though it seems like, well, I'm going to simplify first, then rationalize the denominator, and then simplify again. Well, if we do that, if we simplify first, notice how we automatically went into, pointer. We automatically went into 2I to the 4th just by simplifying it. So all we had to worry about was I to the 4th was. But here we have to do a lot of manipulating with our I to the 6th, our I to the 2nd, right? There's a lot more work done here. So does it lead us to the right answer? Both of them gave us 2, so that's fine. The problem is the work ethic behind it. Are you going to mess up? Are you going to make a simple mistake? So my advice is to simplify first, then rationalize, then simplify again. All right, back to our math problems, okay? So, number 3. Now, notice here, this problem looks a little different, but again, we're just simplifying fractions. So, the first thing is, can we simplify this? Well, I do see 3 numbers, right? Remember, when there's a plus sign or a minus sign in between those, we cannot separate them. Everybody has to be divisible by the same number. All 3 of these are divisible by 2, right? So, mathematically, all we're doing is dividing everything by 2 to simplify it. 8 divided by 2 is 4 plus 4 divided by 2 is 2I, and 6 divided by 2 is 3. This should be in green because that's our first step, was just simplifying it. So if we do that, are we done? Is there an I in the denominator? Because that's our biggest rule. The I in the denominator is improper. Did we simplify it? Yes, we did. There's no I in the denominator. We are done with this problem. We get to move on. All right, here goes the next problem. So first thing we're going to do is focus on, can I simplify this problem? Okay, so can I simplify it? It has to be, there's 3 numbers, so it's 10, 6, and 9, all divisible by the same number. No, it's not. Do we have I? There's 3 I's. There is not. So there's nothing that can be simplified. So now we're going to step 2, which is rationalize I denominator by multiplying it by I over I. Okay, well, negative 9 times I, negative 9I times I is just negative 9I squared. Now, I like to focus on one part at a time. Like, I'm going to just continue on with the denominator, and then I'm going to move on to the numerator. Because to me, it just makes it a lot easier if I just focus on one job at a time. We know that I squared is just negative 1. So negative 1 times negative 9 is positive 9. Cool. So that's that part. Now, the numerator, when we multiply by I, we can't just multiply the 6i by I. We have to multiply the entire thing. So we're going to multiply I by negative 10, which is negative 10I. And then 6i by I, which is 6i squared. Well, what do we know about 6i squared? The I squared is negative 1. So 6 times negative 1 is negative 6. And then that negative 10i will just stay the same. So congratulations, we did it. The answer is negative 10i minus 6 over 9. Double check. Is there any numbers that we can simplify Do we have three of the same numbers that we can make this simple? No, we can't. It's 10, 6, and 9. It didn't change. Is there an I in the denominator? No, it's not. We are done with this problem. Okay? Take a moment. Pause it. See if you can do this problem on your own. And if so, congratulations, right? Here we go. So first thing I want to do is simplify this. These are all divisible by 4. So when I divide all these by 4, I get 3 plus 2i over a negative I. For the sake of this problem, I'm actually going to call this a negative 1i because 4 divided by 4 is 1. Sweet. Step 2, rationalize the denominator, multiply everything by I over I. So what do I get? Let's focus on the numerator first. I get 3i plus 2i squared. Okay. So what do I know about I squared? That's going to be a negative 1. So 3i minus 2. So 2 times negative 1 is 2. Now we're going to focus on the denominator. Negative 1i times I is negative 1i squared. And what do I know about I squared? It's negative 1. So negative 1 times negative 1 is 1. Okay, technically speaking, this is correct. This is the right answer. It is not wrong. But if we wanted to clean some things up, if we wanted to know what it would look like on a test, well, first thing, anything that's divided by 1 is that number itself. So this is just 3i minus 2. Proper format is for the real number to be in the front. So we're going to be negative 2 plus 3i. This is the type of answer you would see on a multiple choice test. This, to me, is an acceptable answer if you were writing it out. Okay? But proper, the most correct answer is the one that's in the box. Okay? And I'm going to actually take away my boxes because if you know, no boxing our answers. But that's the proper way to write this. So if you did it correctly, congratulations. Conjugate. The next part of this is multiplying by a conjugate. Okay, we're still in the dividing section. But I want you to notice something. What happens if I multiply this by I over I? Well, I get 8i over negative 9i minus 4, right? Because that's going to be an I squared. That's going to change to a negative. Well, it's still an I in the denominator. So what if I did it again? I squared times I, right? I get 8i squared, which is just negative 8, over multiplying all this by negative I. So I get negative 9 times I squared is negative 1. So positive 9 minus 4i. I got right back to an I on the 4, right? We keep going and going. No matter how many times I multiply by just I get right back to where I started, right? I'm going to keep going in circles and it's not going to help. So what they came up with is conjugate, okay? And a conjugate is just when you multiply by the opposite sign, okay? So conjugate is when you just multiply by the opposite side. So, for example, I'm going to look up get the proper definition. What I'm going to look for is right here, that plus 4. I'm going to change that sign so that I am multiplying it by negative 9, keeping that front side, minus 4i, okay? So when I multiply that, what's going to happen? So multiply by changing the sign between two terms. In a binomial. Okay. So what happens here? Remember what you do to the bottom, you do to the top. So what happens to let's go with the numerator. That one's easier. 8 times negative 9 is negative 72. 8 times negative 4i is negative 32i. And let's look at the numerator. Now this is going to be a little bit more math involved. If you recall, I told you there's going to be a problem that we're going to repeat, and this is the one. Negative 9 times negative 9 is positive 81. Negative 9 times negative 4i is a positive 36i. 4i times negative 9 is negative 36i. And then you should be able to recognize what's happening. 4 times negative 4i is negative 16i squared. The numerator is going to stay the same, so I'm going to rewrite that just for this problem. Now, let's look at it. This 36i and negative 36i cancels out. Look at that. We automatically got rid of our i's. And then what does the I squared becomes? That I squared becomes a negative 1, and negative 16 times negative 1 is a positive 16. So then what happens? Well, we clean this up. We get negative 72 minus 3i over 681 plus 16 is 97. Okay, next thing we got to make sure is, are we able to divide this? Are we able to simplify it anymore? So the goal is to see, can we divide all three of these numbers by 3? So if I'm looking here, that's a 3. 72 is divided by 3. Is 97 divisible by 3? Well, 9 plus 7 is 16. That is not divisible by 3. We are done. Whew. Let's try it again. So our goal to get rid of the I in our denominator, when we have something where we have two terms, right? We have a binomial in our denominator. Notice here, this is a monomial. That's a monomial. That's both in the denominator. We can just multiply it by I. But the moment we have a binomial, we have to multiply it by the conjugate. So what do? We change the middle sign. So I'm going to go ahead and highlight this in yellow so you can focus on the sign. We're going to change that one. And it's going to now be 9 plus 3i that we multiply by. And what do we do to the bottom? We do to the top. Okay. 9 times 1 is 9 plus 3i. Numerator is usually the easiest. Well, for this part, there's a binomial. Just a fact, the reason why we learn how to multiply before we learn how to divide is because we do a lot more multiplying than we do actually dividing. So now we're going to multiply. 9 times 9 is 81. 9 times 3i is 27i. Negative 9 times 3 is negative 27i. And negative 3i times 3i is 9i squared. I ran out of room. What do we notice here? Well, the numerator is going to stay the same. This is just 9 plus 3i. The denominator is going to be 81 minus 9. Why is it a minus 9? Because that I squared becomes a negative 1. So then what do we get? 9 plus 3i divided by 81 minus 9 is just 72. Well, what do I notice? This is a 3. That's divisible by 3, so it's 72 divisible by 3. I can simplify this thing by dividing everything by 3. So my final answer is 3 plus I over, let's see, what is that, 18? No, let's see, 3, that's a 1. 42, that's a 2. I can count. That's a 2, that's a 12, that's a 4. 24, there we go. Oh, that's simple math. All right, so there we are, we did it. Right, we had to multiply by the conjugate. But mind you, I want you to understand that our basic steps are going to still be the same. We are going to simplify, we rationalize our denominator, and then we simplify again. Just when we rationalize our denominator, we just have an extra step. Okay, so why did I say that? Why did I go back to this? Let's look at this problem here. The first thing I want to do is simplify. Can I simplify all these numbers together? Right? It has to be everything that's involved. There are 4 numbers here. I have to be able to simplify all 4. I can divide all 4 of these by 2. So what does that become? Actually, I'm going to put it down here so I'll have more room. This now becomes negative 3 plus 3i divided by 1 plus 3i, because I divided everything by 2. And now I get to multiply by, rationalize the denominator by multiplying by the conjugate. Why is it a conjugate? Because it's a binomial. So that says 1 plus 3i, so I'm going to multiply by 1 minus 3i. Okay, and then we get to distributing. So this problem gets a little longer, but it's still the same process that we've been knowing our entire life in math, right? We're still going to be multiplying the same way. So negative 3 times 1 is negative 3. Negative 3 times negative 3i is positive 9i. 3i times 1 is positive 3i. And 3i times negative 3i squared is negative 9i squared. All right, I'm going to keep going with my numerator. Remember, I told you I like to focus on one thing. I have an I squared here. I have two i's that need to be combined, like terms. So I'm going to go ahead and simplify that, just focusing on the numerator, and that gives me, well, let's focus here. This becomes negative 1. Negative 9 times negative 1 is positive 9. So negative 3 plus 9 is 6 plus 3. 9 plus 3 is 15i. So there's the numerator. And now the denominator. 1 times 1 is 1. 1 times negative 3 is negative 3i. 3i times 1 is 3i. And 3i times negative 3i is negative 9i squared. This cancels out, thank goodness. And so now I have 1 plus 9, which is 10. Great. Now look, can I simplify this again? Can I do any math here? That's a 6, that's a 15, and that's a 10. They're not all divisible by a number. They're all prime to each other, relatively prime. So no, we are done. Your turn. Take a few minutes, push pause, do this problem, and see what you come up with. Okay, I'm going to just work it out, and then you can see if you got the right answer. Multiplying by the conjugate, so 4 plus 5i. Distribute. Put at the bottom, because I don't have no room. 16 plus 20i plus 8i plus 10i squared. That's going to be, 28i. And that's going to be a negative 10, so 16 minus 10 is a 6. Okay. We got 16 and 20i, negative 20i, and negative 25i squared. Sweet. These are going to cancel out. 16 plus 25 is 41. These are not all divisible by the same number. We are done. So did you get it right? That's it. That's our lesson on dividing number operations with dividing complex numbers. If you have any questions, let us know.